Hey guys, back at it again. It's June 6th, 11:30 a.m. Um, so I thought about it a little bit yesterday. Um, I feel like this way of grinding lead code is not the most efficient. Although right now I have how many questions under my belt? I have like 103 questions under my belt, but I feel like there could be a more efficient way of doing this. I want to do the Neetcode 150. So I guess I'm making it even more difficult for myself because I really want to dedicate a time each day to just grind LeetCode and understand the questions. So to get to a level where um um like you give me any one of the Neetcode 150s and I'll be able to solve them, right? Because that is exactly what an interview would look like. So that is what I should work towards. Yeah, I wanna put a sticky note up as well, uh, to constantly remind myself to do that. Like I have a couple of goal setting done as well. Like this is from a temple in Osaka. So what you're supposed to do is you write your goal here, which is to get a good job. And then after you complete that goal, you fill in the other eye, and then you go back to the temple and you place it there. Right. So this is to get a good job. And then a couple more goals. So let's do that. I would want my sticky notes. All right, cool. So the first goal is to get so good at lead code, right? Is get so goddamn good at lead code. This pen does not work. Just give me my regular pen, bro. Okay. I was looking for Sharpie, but I don't know where the Sharpies in my home all went. Anyways, so get so fucking good at lead code, right? Cool. This is the first one. Any need code 150. I'll be able to do. Oops. Hey, baby. What happened? All right, guys. Yeah, my girlfriend just called. She was in a crisis. Anyways, um, so I did three, if you can see here, this, um, you can see the hand. Oh, wait, give me a sec. So you can see here, there are three goals, right? The leftmost one is any LeetCode 150 can do. The second one is finish CS app. So computing systems, a programmer's perspective. So the textbook that I'm working on now, I'm on chapter 3. And then the last one is finish O step, which is the OS textbook, right? And understand everything. Um, so that being said, um, that being said, yep, just gotta work hard. Just gotta work super, super hard. That being said, let's go to the lead code questions. Let's go to neat code questions, right? Neat code IO practice. I'll add this to the bookmark bar. Yeah. So I guess we can do the core skills first because these are obviously core skills, right? Implementing data structures. I will have to do this at some point. Um, oh wow, like these are, so you have to pay for these? Jesus. Blind 50. System design. Oh wow. Beautiful. Okay, well, I would want to, what would I want to do first? So I have to, the whole point is like I have to be able to finish all of these, right? Um, in my brain as well. So just have to find so difficult. Okay, okay, let's see. I should be able to do this like one shot because I've already done this before. So this one would be given an integer array nums, return true if any value appears more than once in an array, otherwise return false. Um, I can sort it. I wanna do this in here. Okay. Um, return true if any value appears at least twice, and returns false if every element is distinct. I can sort it. Wait. Um, I can sort it. Right. There are many ways to do this problem, but and then I can just iterate through it for if in if nums I, this should be -1 to avoid overflowing, right? This equals to num I plus 1, and I'll return true, else return false, right? Should be simple as that. Okay, cool. There's my own solution. Wow, how are my solutions so bad before? Fuck, what happened? Fuck. Oh, I used the map. Okay. Um, I mean, sorting set and length. Okay, anyways, we can do this, right? What? Many has duplicate. Oh, oh, yes. Oh, so there are edge cases. Let's see. If the num's size is 0, right, then return false. And that will work. Cool. Um, and then I'll go to the next one. Valid anagram. Cool. This should be easy. Yeah. Given two strings S and T, return true if T is an anagram. Uh, anagram is rearranging, right? And false otherwise. So, I think the most straightforward way is to use unordered map, and then it would be a character, and then it would be an int, right? Because this would be called frequency. And then for characters C in S, uh, uh, frequency of this will be added, right? And then um and then for character and C and T, uh if frequency in C is equals to 0, then we would return false. Else frequency C minus minus. And then return true here. Believe it's something like that? No? Oh. Oh yeah. What if T is smaller than I see. Okay. Um, so I can just do a simple compare check here. If S dot length is not equals to T dot length, then we can return. Right. Oh, it's a pretty shitty solution though. But I do it before. Sort. Sort will also work, yeah. Sort will actually also work. That's kind of smart actually. Oh, counter, yep, that's what I thought as well. Oh, this is smart. Can this be quicker? Wow, that's very quick. Um, that's very quick. Wow. Okay. Well, I would want to use, oh shit. All right, let's try it. Cool. So it does work. Okay, well, next twosome. Obviously, very classic question. Like first question on Neetcode. Uh, so it's not to add up to target. Um, so I think there's a map question, right? Com. One, let's do that. For for in nums, if uh, size uh, if in if target minus nums I. I think map has this, right? Um, there's a count. No. So if complement dot count target minus nums I is not zero, then you would return I and also complement and if it doesn't, then you would add. Oh, no, no. Then you would add complement uh, equals to this. So, um, so 9 minus 2. So I couldn't find 2, right? Then I'll add 7. I couldn't find 3, so I'll add 3. I couldn't find 4, so I'll add 4. I could find 4. Um, and that's right. Fuck. What? If I can't find nums I, If I can't find the complement, no, then what it would be 3 will have 0. And then 4 will have 1. And then I'll find, why would it output 2 and 0? I can't find it. If I can find it, count should be contained, so what the fuck? Why would it be 0? Return 2, and so this is wrong. Complement 6 minus 4, which is 2. Well, should be this, huh? Does it work? Okay, it does work. Holy shit. 吓死我了. Oh, here we go. Here we go. Bro, what? What? It literally does. Oh, so this is C plus plus 20 up. Okay. What does find was a return? An iterator. What does count return? Whoa, 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 chill. What the fuck? Number of elements with key. So this can count, right? Wrong answer. Okay, I cannot return it at, okay, guess. this. Okay, there we go. So Neetcode has other restrictions as well. Group anagram. Okay, I have done this. Group anagrams. Let's try it. Given an array of strings, group the anagrams together. You can return the answer in any order. I see. There is no strings, and strings can be rearranged to form fact. Hmm. Interesting. Hmm. So the output would be this, right? So I'm thinking if I sort them, thinking if I sort them, then they'll be segmented into, right? They'll be segmented into different anagrams. I think that will be the most easiest way, right? Then now, um, I could sort each string as well. I'll sort each string as well, and then how do I do this? Um, and put them in a map, and then every ASCII value will be equals to the thing. That could work. Okay, that could work. So like I'll do like this is just what I'm coming up with, right? Uh, it would be the ASCII value, and also it would be a vector string, right? And then this would be, I guess, an adjacency list kind of. And then for string in strings, right? Each string uh, string will be equals to for character in string um plus or equals to C, right? That will be the ASCII value. And then adjacency list of push back, push the string into it. I'll do that for every single string. And then I will have a result here. And then for I'll iterate through the adjacency list, iterate through the map, and then to work, right? Yeah. Fuck. Um, Del and L. Wait, so Del and L have the same ASCII values? Ah, I see. Okay, okay, okay. Oh, that's smart. So the ASCII value wouldn't work. Um, to a set, but would that be kind of stupid? An order set of characters, right? And then um uh C of C will push back this. This should also work, right? Can't do this? Fuck. Wait, can I do that? Wait, why can't I do this though? Call to implicitly deleted default constructor. Hmm. Oh, I can just sort the string, right? Requires to string, right? Uh, Does that work? Should work, right? Should work. Nice. See what I wrote before. Oh wow, literally the same idea. Okay, cool. Um, guess I'm not stupid. Okay, cool. Um, it's kind of cool that I came up with the same solution, literally. Right. All right, next. Top K frequent elements. What's this? All right, given an array, integer array nums, and an integer k, return the k most frequent elements. You may return the answer in any order. An integer k. k most frequent elements. So we'll do 1 and 2. K most frequent element. Pull up. Must be better than n log n, where n is the array size. Mm, I'm thinking like the most frequent, then it has to be in the middle, right? So I'm thinking it's some sort of binary search, right? N log n, n log n, like binary, uh, time complexity algos, right? But look at this. N log n is all sorts, right? Um, I searched the middle. Greatest elements. I sort it. How did I do this actually? Um, I turn into a map, then I have frequency, and then how do I find the maximum in, how do I find the maximum within a map? I'll turn the frequency into a key, but that's kind of stupid though. I don't know if that's the way. A number and frequency. The most frequent elements. I really don't really know how to do this. So now I have 1 = 3. Oops. These are the keys. And those are the values. And then so I will ask, I'll have a vector of int called because if I have a vector, then it's easy, right? I'll iterate through frequency and then find the max. Okay, I'll just do it the retarded way and then see how people do it, right? Um, I don't know if this one works even. Right. So I'll find zero first, and then um, if iterator second, which is the frequency is bigger than max frequency, and max frequency equals to iterators. Okay, now I have max frequency, and then I'll loop through it again. I'll actually have the vector of this. Right. I'll loop through it. I'll find max frequency. And res dot pop back. No, I can't do that. No, this is a very stupid idea. There has to be a better way. There has to be a better way. I sort it. Is it a heap question? I forgot how to do this. Bucket sort. It's a bucket sort. So I first create a vector of in of no this many and that, right? And then for nums of for in nums uh, bucket dot n for plus plus. So now every indices will have O can be however many though. N buckets. Number of unique elements. Number of unique elements. The fuck? I don't really remember this. Yeah, I used the max heat. Yeah. Oh my God, what the fuck? Did use a max heat. Okay, let me practice my heaps. Okay, now do a max heap priority queue pair in frequency. I don't really do this. Frequency. Ah, okay, I remember. Right. And then priority, and then for auto frequency number and frequency max heap. Yes. Push and let me get, let me get, I'll group it by frequency first, right? And then n first, right? If max heat dot size is bigger than k, then I will pop the last one. And then the last thing to do is to do this. Or no, while max heat is not empty, whereas now push back max heat. Top, not top. Let me get first. Max heat. Top. Oh shit, I didn't plan on hitting submit. Don't exactly know what the difference between these two are. It's not a pointer. Is this the pointer? This is not a pointer. Hậu, Dừng咩啊？我想問。Mm, no push. Why is it not push? Why is it not push? Wait, max heat. Awesome. Is this second? Wait, I have to eat, so I'm gonna finish this later. Give me a sec. All right, guys, we back at it again. All right, let's figure out what the fuck's wrong with this. So I'm sorting according to the first one, which is the frequency and the number itself, right? Uh-huh. While max heap is not empty. Res pushback. Why would it be 2 and 3? The fuck? I'm so confused now. Yeah. So it's the problem with this. OK 啊，可能打波噶嘛。好，好，冇問題啊。咩啊？出嚟講咩？哦，好啊。What the fuck? Why is that wrong? Oh, then this will pop. This is popping the biggest. Oh, that's why I have to do this. Okay, yeah, that makes sense. Right. Oh my God. Okay, I struggled with this one. There's no good. 叻條毛咩？完全唔買色啊，張。Another way would be doing and then the container, right? Uh, it's a min heap. How would I do it? 唔係，我有得諗啊。This would be a min heap. In this case, I can do this. JBzers 唔使 Right, I think this will work because I can return them in any order. Boom. Boom. Yeah, I mean, okay, whatever. Let's go next. This is one that I've solved as well, so I'm not supposed to spend this much time on this, but unfortunately I fucking suck. So let's go next. Encode and decode string. Okay, this is one that I have not done before. So this would be a good challenge. Bruh, 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 bruh. Fuck. Excuse me. What? What is this? What am I supposed to be doing with this? What am I supposed to do with this? What is encoding and decoding? I've never come across this concept before.
Write some more Neetcode today. So today let's solve the problem encode and decode strings. So you can tell the interface is a little bit different this time, and that's because we are going to be solving this problem on Leetcode because this is a premium Leetcode problem and we can solve it for free on the website Leetcode. And also, this is a problem from the Blind 75 list, a list of 75 common Leetcode questions that we've been tracking on this spreadsheet. The link to this will be in the description if you want to take a look. And we're pretty much done with the main problems. I'm going to be solving another one today, a premium one, encode and decode strings. This is a pretty decent problem to understand, so let's get into it. So it's a bit of a design algorithm because we're going to have two different functions that we want to implement. So we're given a list of strings, and we want to write two functions. We want to encode this list of strings into a single string. And you can kind of see that down here. We're given an input list of strings, Leetcode love you, and we want it to be a single string, such as this one in the bottom right. And then the decode is just going to be the opposite of encode. We're going to be given a single string, and we want to be able to convert this string back into that original list of strings that we were given. And it's up to us on how we want to design this algorithm. But the tricky part is going to be that the basic assumption is that in our input, we could have any possible character in the inputs, not just limited to lowercase a to z. So the difficult thing is going to be how do we create some kind of delimiter between each word? How do one word ends and another word begins? That's kind of what we're going to be focusing on. So let's get into that solution. So suppose we were given two strings like this, neat and code, and we want to convert it into another string, basically into a single string, right? So a naive way would be something like this, right? Just say, okay, neat code. Now the problem is, okay, we did that, the encode was fine, but now we want to decode this back into the two original strings that we
Right,
have.
then how do you
There's no way for
separate it, right?
Because we can't remember where one word ends and another word begins, right? So we need to have some kind of character or something to separate words. What if we used a pound sign or something, right? Something like this, or any character, maybe a question mark or something, right? This is like our special character. That's what's going to separate words for us. So in this case, it works out, right? We'll go character by character in the input. Once we get to a pound sign, okay, we'll say that this word ends. So we'll say, okay, we have the first word neat, and this is not included in any of the words. So we skip it, and then we get to the remaining portion, code, and there aren't any more pound signs. So that works out in this case, right? But basically, our assumption when we're using this pound sign is that the pound is never going to actually show up in any words. What happens if we have a word, suppose in our word code, in the middle of the word, we have a pound sign, right? There's no reason why we can't have something like this. So in that case, what when we take this and encode it, we're going to get something like this as the encoded string, right? And then when we split it, we're going to have three different words, neat, co, and de. But in the original, you can see we only had two words, but when we get our output, we're going to end up splitting this into three words, which is not what we
Yeah,
wanted to.
then I find a delimiter that is not part of the UTF-8 characters, right? Only knows about raw char vowels. It knows nothing about particular characters and codings that use char to hold encoded values. Many common UTF-8 implementations use hard encode code units. Uh-huh. UTF-1 that provided a byte stream encoding of its 32-bit code points. Well, okay, anyways.
To do, right? We want to transform it back into what was originally given to us. So having just a single special character delimiter is not going to work because that delimiter could actually show up in some of the words. Wouldn't it be nice if in the encoded string, we somehow already knew how many characters would go in the first word, how many characters would go in the second word, et cetera, et cetera. So then we could just say, okay, let's take the first four characters, encode it back into the first word, then take the next five characters and code it into the second word. So how could we, do something like that? Well, one way would basically be by maintaining some kind of array, right? When we're given this inputs list of strings and we want to encode it to a single string, we can, for every single word, basically have an integer, right? The first word is 4 characters, the next word is 5 characters, etc. But then where are we going to store this list? Because this is a valid solution if we're storing this list somewhere, but basically in the description, they don't want us to store any kind of state variable. This encode and decode needs to be stateless. So when we have this list 4 or 5, we cannot store it in a separate data structure. Is it possible for us to store it in the string
as well?
How about when we're encoding this, we want to know, okay, starting at the beginning here, how many of these characters are going to be in the first word? Well, why not just put that number at the beginning, right? 4 at the beginning of this encoded string. That works because then we can look at the beginning, transform it into an integer. But one thing is, what if the word itself had some integers in it? Well, now we need another delimiter, right? We're going to have our integer always at the beginning. There's always going to be an integer at the beginning. The string is always going to start with an integer. That integer is going to represent what the length of the following word is going to be. But we're going to have a delimiter in between the integer and between the word itself. So basically, we're going to read each character until we reach the delimiter. And once we reach the delimiter, we're going to take all the characters that we just read, which are going to be transformed into an integer. So this 4 is going to be mapped to 4. And then we're going to count the next 4 characters after the delimiter, which in this case is going to be pound. And that works because we're only going to read one delimiter. We're always going to expect a single pound sign no matter what, right? So even
Okay, I think I kind of understand. So I want to so this would be vector of integer, right? Called string length, and that will take strings size. And also that would just be string of size, right? And then for auto string and strings, string length will push back string dot length, right? So now string length will have the string. Yep, we'll have the length of each string within that maps to the same position. And then what I want to do would be string. So the encoding will be it will be a string uh result, and then uh, for in I is smaller than string dot size plus I, and then res will plus or equals to first, it will plus or equals to I have to cast it to string, right? To string length dot I, right? I think that's how I do it. Or it's just to string. Or it's simply to string. Okay, fine. Okay. And then I will add the pound character. And then I will add string itself, right? And then that will be the encode. And then decode will be so that will be our result. For character. So I should have a pointer, right? I should have a pointer. Smaller than S star length, right? If it's equals to length, then it means it's reached the end, right? While current is smaller than S dot length, um, so current will be why do I even need this pound? I don't even need this pound, huh? Right? So the first one will be to int. Is that available? Character to int. No, 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 no. It's not to int. It's something like that, I think. Right? That will be the word length. Yo,
It's here.
huh? Wow, so pretty, so pretty. Một cái gì người đâu? Thứ này người đâu ra? 그 너희 자오 옆에
너무 줄였었거든요. 까오겠어.
별로 잘 근데 지금 많이 모르죠.
公司係我中意咗出嚟，
我觉得是
你真係幾中意啲 pop color 呢份色嘅，我中意 music color 先。
都就佢啦，都係嗰個乜數咯。我咁嬲着啦，你張卡咯。
都係啲攞綠色咯，真係。嚟到呢個色淡靚啦，我唔再想。如果做有衫款色埋都多咗幾萬塊出嚟咧，但係你平時帶到嘅。我長期會啲，我說我冇攞過，我
Let's continue. Okay. And then so the first word will be, so it has to be something substring, right? Um, right. And then what are the arguments? Three, five, 0, 1, 2, 3, and then 5. And then, okay, cool. So it will be substring, and then it will be term plus 1 and word length, right? And then current will be equals to current will plus or equals to word length. Something like that, maybe? I don't see why that would work. Oh, sorry. No? The fuck? What's wrong? Lệnh nhất nhì sam say. This one. Okay, so it's all zeros, which is not correct. So string length equals to strings dot size. Yep. And then for each string, I'm pushing the string length into it, right? And then there's the final string equals to, let's just do that. It's an empty string. And then for int I equals 0, I is smaller than strings dot size. So for each string, I am adding to string. I added that. And then next I'm concatenating res plus or equals to strings I. So I'm actually adding the string right into it. And I'm doing that for every single string. Current will be 0, and then while current is smaller than s dot length, int word length is 0. Ugh. It was the first character. And then res dot pushback will be substring current plus 1, and then word length, and then current will be. Why is that wrong? What happened here? Okay, why are these all zeros is my question, right? So something is wrong here. Um, So if I two-string it, it should work, right? But why does it not work? Something here is going wrong, I feel. Something here is going wrong. But it shouldn't be all zeros. That doesn't really matter. A pushback strength. Oh, what? Fuck. What changed? Oh, it's pushing. Oh, right. Okay, fine. Fine. Yep, I'm stupid. Okay, fine. Because now it's starting with 0, 0, 0, 0, 0, like empty, but there's nothing. So what I should have done is string dot I guess. But let's do this. There's no matter. Yep. Okay. This should be it, I think. I think it should work. Fuck. Um, what happened here? Why is there a bunch of garbage? Why is there a bunch of garbage? So my string would be two, we, three, say, one, no, three, yes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 Lego, right? Zero. Okay, this is wrong. Understood. So I can't do this. So I have to go into ASCII. No, I have to go ASCII to int, right? Right, because what if the word length is is double digits, right? Mm, that's why you need the pound. Understood. That's why you need the pound, because it's double digits. Okay, understood. Wow. So equals to current, right? Right. And then now it's a pound. And then word length, equals to what was it? It was right here. Stowy. String to integer. Right. String to integer word length. Yep. And that'll work. That should work. Fuck. What, man? Important. Oh, show me the money. Yes! Yeah! I did it! I did it! Okay, learn something new. So there's string to int, and there's int to ASCII, right? Int to ASCII, and what else are there? Int to ASCII, ASCII to int. Yeah, I mean, ASCII to, what's that? ASCII to long. Okay, well, learn something new every day. So there's string to int, and then there's int to ASCII. Cool. Integer to ASCII. Yeah, okay. Well, I want to know how int to ASCII works. Oh, converts it to a string. Hmm. Int convert to a string and then string convert back to an int. I see. Pretty good. Pretty good. Is there ITOS? ITOS. So there is a toString. So there's ITOS STOI and ITOA. ITOA is the same as toString. The toString is standard, so I should use toString. Okay. Okay. Well, cool. Anyways, so the legal part of today is done. I'll continue tomorrow. That's pretty cool. That is pretty dope because I actually finished a, let's see what this is. Return an array output where output I is a product of all elements of nums except num I. Huh. Okay. Oh yeah, I could. If I multiply it all, what was the submission like? Time limit. Okay. If I multiply it all, hmm, I'll work on this tomorrow. This doesn't seem that simple. So cool. Um, peace. Goodbye. I'm gonna go do CS app now. Fucking assembly languages eat shit. Peace.